Hello everyone, this is Mr. Underkoffler. Today we're looking at the guided notes called Finding the Area and Perimeter of a 3D Figure Space. Follow along as I read this out loud. Before we practice finding volume or surface area of a 3D figure, we must make sure we know how to find the perimeter and area of a 3D figure space. Why? Because those are components of their formulas for volume and surface area. So let's get started. Capital B represents the area of a 3D figure's base. Now notice, that's an uppercase letter, not a lowercase letter. Spoiler alert, lowercase b would not be area. Lowercase b would be a line segment called the base of a trapezoid or a triangle or a parallelogram. It's now uppercase B to represent the area. You're used to uppercase A being the area, but here for the area of the base, we're going to call it uppercase B. Now, having said that, we're still going to use area formulas from our formula sheet to get the value of uppercase B. Now, uppercase P is going to represent the perimeter of a 3D figure's base. All right, so let's do some examples. The directions say for each solid, find the area of the base and the perimeter of the base. Now, we should probably make sure we know which side is the base before we even try to find the area or the perimeter of it. Problem number one, the base is the rectangle at the bottom. But I don't want you to think the base is always at the bottom. Often, the base can be bases, two of them, if they are prisms. And bases are not always going to be at the top and the bottom. They're sometimes going to be in the front and the back. Now, how do I even know which shapes then to consider the bases? With prisms, the bases are the shapes that are parallel and congruent to each other. So did you notice on number 2, the triangle in the front is parallel, meaning going in the same direction, and congruent, meaning the exact same size as the one that's in the back. So on problem number 2, it's the triangles that are the bases, not the rectangle at the bottom. And the first thing I would do on all of these problems is draw a quick sketch of the flat shape that is going to be the base. Problem number 2, that was the triangle. Now, let's go back to problem number 1. Why were the triangles not the bases here? Because these triangles are not parallel to any other triangles. Instead, these triangles meet up at a point. This is what we call a pyramid, not a prism. And a pyramid only has one base. And coming off of that one base will be a bunch of triangles meeting at a point. That's why problem number 1, the rectangle at the bottom, was the base. Because that's the shape where all the triangles are coming off of it. And like I already said on problem number 2, the first thing I do on all these problems is I draw a sketch of the shape. Now, if your base, the shape of your base, is a rectangle, then you will use the area formula of a rectangle. But on problem number 2, our bases were the triangles. So I will use the area formula of a triangle. Do you see how this is catching on here? If my shape, that was the bases, would have been trapezoids, then I would use the area formula of a trapezoid. If my bases were parallelograms, I would use the area formula of a parallelogram. So I hope you're catching on here. Whatever shape is the shape of your base, that will determine what area formula you use. Okay, so back to problem number 1. I do formula, substitute, solve. I simply call capital A, capital B instead. They're pretty much interchangeable here, and that's going to give me the area of this rectangle. Perimeter doesn't normally have a formula, but a rectangle does have a perimeter formula found in Pennsylvania's formula sheet. So I went ahead and used it. Formula, substitute, solve. But it's basically just taking the 2 lengths and the 2 widths and just simply adding them all together. It's just 2 times length, 2 times width, and then add. Problem number 2, not a big deal. We have a triangle, so I use the area formula of a triangle, formula, substitute, solve. One thing you should remember is that the lowercase b, which stands for line segment called a base, and the lowercase h, which is the height of the triangle, they will always meet at a right angle. Sometimes the right angle is going to be in the corner, if it's a right triangle. Other times it will not be, and you will see a dashed line for the height. But always look for the right angle so you know which measurements are the lowercase b and the lowercase h. Clearly, that was not the 38.2. Once I get my area, then we get to perimeter, and you do not need a formula for perimeter. You can just add the exterior sides of the shape to get the perimeter. I could have even done that back on problem number 1. I could have just added these exterior sides, realizing there were two 38s and two 11s. So on the triangle, we have sides 28, 26, and 38.2. And it's a good thing that I drew this triangle, because if I didn't, I might have accidentally added the 41 as well. And I hope you can see on this drawing, the 41 is not a side of the triangle. Instead, it's a side on the three rectangles that go between the triangles. But we only want the perimeter of the base, which is the perimeter of the triangle. So it's just the three sides of the triangle added together. Okay, I would like for you to try problem number 3 and problem number 4 on your own. I would highly recommend drawing a quick sketch of the shape of the base and labeling all the sides of that shape. If there's a right angle, make sure you draw the right angle so you know who's your lowercase b and your lowercase h. Doing that will help to prevent you from adding a measurement that is not actually on your base. Like on problem number 2, we didn't want to add the 41 to get the perimeter because the 41 was not on the triangle. All right, so hit pause, do 3 and 4, and then hit play once you're done and you're ready to see how you did. Okay, did you already do number 3 and did you already do number 4? If not, hit pause now because here I go going over it. Problem number 3. We had a triangle in the front and a triangle in the back, kind of like number 2. So those triangles are the bases, not the rectangle at the bottom. So you should have drawn a sketch of the triangle and you should have labeled it with its 3 measurements, the 1.4, the 2.9, and this left side was not shown on the triangle in the front, but it was shown on the triangle in the back. And there you go. If you realize you already botched up number 3, please feel free to hit pause right now and start fixing your work and your answers, because obviously if you identified the wrong shape as the base, if you thought the rectangle was the base, then that totally messes up your area and your perimeter. All right, continuing on. Area formula of a triangle, 1/2 times lowercase b times lowercase h. I'm going to change the capital A to capital B, and I'm going to find the right angle. Here it is. And therefore, the 1.4 and the 2.5 are my lowercase b and my lowercase h. All right, in any order you want. I don't care if you flip-flop the 2.5 and the 1.4. Doesn't matter. I changed my 1/2 to a 0.5 because everything else here was decimals, so I figured I would just make that a decimal. You don't really have to. If you want to keep calling it 1/2, that's fine. All right, so formula substitute solve. The area of the triangle is 1 3/4, 1.75 square centimeters. Did you put the little 2 on the centimeters? Please check. Area should get squared. Not perimeter, but area should. All right, speaking of perimeter, you're going to add the 3 sides of the triangle. So in any order, 2.5, 1.4, and 2.9, not the 2 centimeters. This 2 centimeters was on the rectangles, was not on the triangle. So only add those 3 measurements together to get the perimeter of the triangle. No squared on the centimeters for perimeter. All right, problem number 4. Did you recognize that the trapezoid in the front and the trapezoid in the back, that's right, this is a trapezoid. How do I know? Because it's a 4-sided figure where the top and bottom are parallel, but not congruent, but the left and right side are not parallel. So that's why it's not a parallelogram and not a rectangle and not a square. This is a trapezoid. So I would have drawn a quick sketch of the trapezoid and then labeled it with the 4 measurements of the 4 sides. If you realize you already botched up number 4 and maybe you accidentally thought the rectangle at the bottom was the base, then please hit pause, fix your work, and then hit play once you're done with all your edits. Okay, the sides of the trapezoid. The left side is 17. The bottom side is 8. The right side of this trapezoid was shown in the back. So was the top side. So that's 15 and that's 16. Skipping ahead to perimeter, you would just add those 4 measurements together. You would not add the 20. The 20 is not on the trapezoid. The 20 is on the rectangles that's between the trapezoids. And the perimeter would be 56 feet. For the area of a trapezoid, I hope you did not use the same area formula as you did in number 3. Because number 3 was a triangle. This is a trapezoid with its own unique area formula. The B1 and the B2, in case you forgot, are always the 2 parallel sides of the trapezoid. So 16 and 18, they are the B1 and the B2. The H is always the side that touches those bases at right angles. So that is normally a dashed line, but on this one it was not. The right angles were in the corners. That's why the 15 was the height. All right, so formula substitute solve. Let's take a look at your substitution. That's right. I forgot I changed capital A to capital B. I don't know if you really have to show that, but here's your substitution. 15, we already said, was the height, and the parallel side, 16 and 8, were your bases. All right, using your calculator, you're going to get 180 square feet. Please make sure you have the little 2 on the corner. And that concludes this very short introductory guided notes on finding area and perimeter of a 3D figure space, which will help to get you ready for volume and surface area guided notes coming up in the future. Thank you for watching. We'll see you next time.